Today we're going to build upon our 6 trig ratios that we've been talking about so far. We're also going to evaluate those more specifically when we're given a point out in space on a coordinate plane. So here's our first example. We're going to let theta be an acute angle in standard position whose terminal side, so its finishing side, contains the point 3, 5. And we want to find the 6 trig functions of that angle. So if we think about this on a coordinate plane, our x value is 3 and my y value is 5. Okay, that's somewhere out here. Okay, so there's a point 3, 5. That creates a triangle from the origin to that point and back to the x-axis. Okay, so here's our right triangle with angle theta. Okay, we want to evaluate the 6 trig functions given that point. Well, from theta, I have my adjacent side would be 3. Okay, that's the x part of my ordered pair. My opposite side is 5 units up from the x-axis, so that opposite side is 5. To find my hypotenuse, that's the third side of a triangle, given 2 sides, I use the Pythagorean theorem. 3 squared plus 5 squared equals my hypotenuse squared. Well, if I square those values and add them together, I get x squared equals 34. So x equals the square root of 34. There's no perfect square factors there, so that is the hypotenuse, root 34. And again, that's the hypotenuse. I'm going to use those 3 sides from my reference angle to write down my 6 trig functions: sine, cosine, tangent, and the reciprocal functions: cosecant, secant, and cotangent of theta. Okay, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. One thing we have to remember is to rationalize the denominators if needed. So I multiply by the square root of 34 on both top and bottom, and I get 5 root 34 over 34. Similarly, for cosine, I get 3 root 34 over 34. Okay, and our reciprocal functions. Cosecant is the reciprocal of sine, so I get root 34 over 5. Secant is root 34 over 3, and cotangent would be 3 over 5. Let's do another example. This time we've got a negative x value, and that's okay. My reference triangle is going to look just a little bit different. Okay, this is going to be off in quadrant 2. So negative 12 somewhere out here, and 5 is my y value there. Okay, so here's my ordered pair, negative 12, 5. Let's draw my reference triangle. Again, we're always going to draw that with the x-axis and the origin, where I have my right angle, and here's my angle, my reference angle theta. Okay, there's theta. Well, my sides would be negative 12 and 5. That's the adjacent and opposite sides. Again, use the Pythagorean theorem to find the hypotenuse. I've got negative 12 squared plus 5 squared equals the hypotenuse squared. If I square, I get 144 plus 25. So x squared, 169. And square root both sides, I get x equals 13 after I square root that value. Okay, so my hypotenuse is 13. Let's evaluate our 6 trig functions: sine, cosine, tangents, cosecant, secant, and cotangents. Okay, a little bit easier this time. I don't have any radical symbols. So sine is opposite over hypotenuse, 5 over 13. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. And our reciprocal functions. Flip those guys over, I get 13 over 5, 13 over negative 12, and negative 12 over 5. Those are our 6 trig. Now, there's a special case, okay, and it's called a quadrantal angle. Quadrantal angle. It happens when we try to draw a reference triangle when one of our sides is 0. Okay, that's not possible. I can't draw a triangle only given 2 sides. Okay, if you think about a point on an ordered pair on one of these axes, okay, with the origin, there is no triangle to draw there. Okay, so our quadrantal angle is an angle whose terminal side lies along one of the coordinate axes. When finding the values of the trig functions, you cannot produce a reference triangle. So we need to come up with some ratios when that happens. Okay? If we look back to our first example, sine is always going to be the y value over the r value. Okay? Cosine is always the x over r, and tangent is the y over x. R is the distance that the ordered pair is from the origin. Okay, we'll elaborate more on that in a second, but r is essentially the radius that point is from the origin, and we'll see what that means in an example coming up here. And we can still evaluate our reciprocal functions by reciprocating sine, cosine, tangent. I get y over r, r over x, r over y, r over x, and x over y. Okay, just the reciprocals of sine, cosine, and tangent. Okay. Again, I talked about this r value, and r is the distance from 0. We'll keep that in from the origin rather. So we'll keep that in mind for that r value. Okay, point P is on the terminal side of angle theta. Evaluate the 6 trig functions for both of these problems for their particular angle. If the function is undefined, we will indicate as such. So let's write our 6 trig: sine, cosine, theta, and tangent, cosecant, secant, and cotangent. Okay, given those ratios that we wrote down on the previous slide. Sine is y over r. Okay, x and y are the ordered pairs. The 0.40, if I quick draw a little reference graph here, the 0.40 is here, 2, 3, 4. Okay, that's an ordered pair. R would be 4 in this case. Okay, the distance that my point is from the origin is R. Okay, for our next example, when we get to that one, okay, -7 is 7 units away from the origin, so R is going to equal 7 in that case. So sine of theta, y over r, 0 over 4, which is 0. Cosine, x over r, 4 over 4, which is 1. Tangent, y over x, 0 over 4, still 0. Cosecant is the reciprocal of sine, 4 over 0. Can't divide by 0, undefined. Secant is the reciprocal of cosine, 1. Okay, 4 over 4 is the same as 4 over 4. And cotangent is the reciprocal of tangent, 4 over 0, which is also undefined. Example 2, where I have x, y, and my r, the radius, think of it kind of as a circle. If there was a circle around here, okay, that r would be 7. Okay, that distance, the point that the distance that the point is from 0, from the origin, is 7 units. Okay. So again, we're finding our sixth trig based on that: sine, cosine, tangent, and our reciprocals. Okay, sine is y over r. Again, it's a positive distance, it's the absolute value, so I get -1. Cosine is x over r. Okay, x over r, which should be 0 over 7, which is 0. Tangent is going to be y over x, -7 over 0, which is undefined. Okay, cosecant, reciprocal to -1 is -1. Secant, 7 over 0 would be undefined. And cotangent, 0 over -7 is 0. I hope that helps. Okay, you can always reference those 6 ratios that we developed with y, x, and r in order to help you find these 6 trig ratios for those quadrantal angles.